Good morning, good afternoon, and good evening, everyone, depending upon where you have joined from. And welcome to another webinar from Data Platform Geeks. Today, our session is on machine learning basics using R and Python. And our speaker, Deepak Pradeep Kumar, who is a senior software engineer from Microsoft. My name is Satya Ramesh, and I will be the host for you for next 1 hour. And Aarthi Nambiar, she's helping me with moderation for today's webinar. So before we move forward, a quick word about who we are and what we do. eDominer Systems has a lot of brands under which SQL Maestros offers a lot of advanced trainings on SQL Server and Microsoft AI and data platform related technologies. And SQL Maestros also offers a lot of self-paced learning solutions like learning kits and hands-on labs. So recently SQL Maestros is coming up with video courses. I'll talk about video courses on SQL Server in a couple of minutes. And under eDominer Systems, we also have Peopleware India, which is our corporate training unit, and Expand SM ERP, a famous ERP product. So you're all part of Data Platform Geeks community. Data Platform Geeks, earlier it was called as SQL Server Geeks. These two are different communities. Both of them were founded by Amit Bansal. He's a president and founder for both of them, under which we do a lot of free webinars and free events across India. And once in a year, we do annual summit called Data Platform Summit. Recently, we have concluded Data Platform Summit 2019 in the month of August in Radisson Blue. You can see the dates there, August 19 to 21 pre-conference trainings and 22 to 24 regular summit. So Data Platform Summit was attended by 900 plus attendees from 300 plus companies, and speakers from 20 plus countries traveled down to Bangalore to deliver sessions. There are more than 50 plus speakers delivered 100 plus sessions. You can visit all the links that are there in chat window to learn more about Data Platform Summit 2019. It is a quick picture where Data Platform Geeks team and eDominer team on stage on Data Platform Summit 2019. So this is the DPG core team, Amit Bansal, founder and president of Data Platform Geeks, and you can see Manohar Punna, who is the vice president, and you can see all regional mentors across India and various countries as well. If you want to become a regional mentor for Data Platform Geeks, you can fill up the form. You can directly go to Data Platform Geeks and you can apply as regional mentor for Data Platform Geeks. So these are the eDominer teams that help us organize these events. And special thanks to Microsoft for supporting us unlimitedly. You're already a member of Data Platform Geeks, so remain as a member of Data Platform Geeks and make sure our Data Platform Geeks domain is whitelisted so that you will never miss any of our updates. If you remain as a subscriber, you'll get a lot of free videos, labs, magazines, and host of other learning material as well. And watch out for a mail from events at Data Platform Geeks. Whitelist that particular email ID so you won't miss out any of the updates from Data Platform Geeks. So here are the few social channels you would like to join: Facebook group and LinkedIn group and Telegram group. We do a lot of conversations there. Facebook group is largest group on SQL Server in Facebook. You can join there. Beyond this webinar, if you have any questions, you can always ask your questions there. Someone from the community or experts answer your questions. And yes, we record all our webinars and we'll put up our webinars under SQL Server Geeks YouTube channel. Links are there. You can subscribe. And we also record a lot of free videos on SQL Server performance tuning and T-SQL as well. And all the videos are available under SQL Maestros YouTube channel. Again, the link is already there in chat window. And a Telegram community is there where you can join and you can ask your all technical related questions. Someone from the community and experts will answer your questions. So before I hand it over to Pradeep, a couple of questions. I'll launch a poll. You can answer you can put up your poll option there. So the first question is, what is the level of understanding you have on machine learning and deep learning techniques? You can answer your answer there. 100 is basic and 500 is advanced. And the second question, if you see, have you attended? This session was already delivered as part of Data Platform Geeks free event in Hyderabad. If you have already attended this session, you can answer there. And the third question, if you can see, do you wish to see more webinars and on machine learning and deep learning techniques? You can put up your response there. So these are the questions. I'll just put this poll for a few more seconds and then I'll announce the results. Yes, we can close. I'll just give a couple of seconds again to answer to people to answer. Yes, here are the results. For the first question, most of the people have basic level of understanding. Only most of the people here, 70% of the people have level 100 understanding on machine learning. So most of the people here are basic people, and 93% people have not attended the session that was conducted in Hyderabad. And yes, almost all of them wants to know more about more webinars on machine learning and deep learning. With this, I'll hand it over to Deepak. Deepak, please take ahead.
Thanks, Satya. That was very informative. Thank you so much. Hello, good afternoon, good evening, good morning, everybody. Uh, Let me share my screen and we can start the session. Hi, all. My name is Deepak. I'm from Microsoft. I'm a senior software engineer in Microsoft. So, welcome to the machine learning uh, techniques using R and Python. So this is one of the sessions that I delivered in the month of April when we, started having these events on machine learning in Hyderabad. So this is again, for the sake of webinar and to have the series of webinar without any breaks. We have started to, deliver this session uh, so that we can have the continuity of all these, of the complete machine learning algorithm techniques. So uh, not more about me. I'll just try to skip this. So I have 13 plus years of experience. So I've worked on, in my stint, I've worked as a database developer, administrator, web developer, and business analyst, and also, software engineer. So I have multiple degrees. Recently, I have completed this executive program with advanced business analysis from IAMA. So I've been working on data science, using deep learning techniques from at least 2 years now. So today's agenda, we're going to be starting to know a little bit about machine learning. So we'll start to know what is machine learning, what is statistics, a little bit of statistics that you need to have, a small bit of understanding before we start the algorithms, even for the linear regression also. And I'll introduce you to Python and R, but I will not help you with installing R and Python. What I'm going to do is to say that, okay, we can install R and R as a compiler, and then you have the R Studio IDE, which you will install on top of it, and that is where you can do the installation and then keep the system ready. So I can share the code with you, and then I will also share my GitHub repository code, so you can download it from there and then start running that code on your R or your Python. Uh, Python interfaces. So machine learning algorithms, what we're going to talk about is the linear regression, multiple linear regression, and I will walk you through the demo. So after that, I will, if time permits, because as far as I have gone through the session, I think like until the demo of multiple linear regression completes, it takes at least about 45 to 50 minutes or close to about an hour. I will also have to have some time for Q&A so I can answer all your questions. In case if we are not able to cover classification techniques, we will certainly have that in the upcoming webinars, or you can attend another upcoming event on Saturday, this Saturday, the 23rd of November in Hyderabad. For people who are in Hyderabad, you can just walk into this session. That's going to happen on Saturday, and I will continue with the classification techniques. So um, yeah, so to start with, machine learning. There's a quick machine learning introduction is that a typical computer program, when you say, okay, count 2 plus 3, what is 2 plus 3? Or if you write a program to get the name, age, and location of a person, write an API for to fetch or to get the name, age, and location from another application, how many ever times you run, it will just get that same thing done. It will just get the name, age, and location. That's the typical computer program. But machine learning program, what happens is, even without the specific instructions, because of the algorithm or the formula that is running, the statistical formula that is running behind the scenes, it will try to discover a lot of insights in the data. And that is what differentiates the machine learning programs from the normal computer programs. So I write a program, and then I ask the computer, or I ask the machine learning algorithm to do something. When it's continuously doing something, it will discover a lot of pattern, and it will come up with some more predictions which we would not have also even thought about. And that is the machine learning algorithms. That's what machine learning algorithms can do, in contrast to the normal typical computer programs. So there are three types of machine learning algorithms, like supervised, unsupervised, and reinforcement learnings. Supervised learnings is pretty straightforward. Like, I have the age, the number of years of experience, where everything is labeled, and then I also give the salary. So I give a set of data. I will train that data with some of the variables which are labeled already. And if I ask to predict the salary, or if I ask to predict something, it will immediately predict it, because it's like supervised. We have all the data labeled, and that is what supervised data means. Most of the data that you see is pretty much supervised. And unsupervised is like where I just define the features, and then it groups the features based on the similarities of the features. And then based on those groups, then I will label it. Like, let's say, for example, if I have to have apple and orange, and if I say, okay, it's red in color, it's little waxy, and it's pretty much round in color, it will start grouping it based on the features. The algorithms start grouping it based on the features. Like, it makes it as a cluster, and those clusters will be like for all these similarities of these features, as I mentioned. So if for orange, it'll be like orange in color, oval or little circular, and then it's little rough on the skin, but it apple is little smooth and it's waxy. So all these features, I'm not giving a particular label key or label like this is the fruit and this is apple or orange. I'm just giving the features. Based on the features, my algorithm will differentiate it and give me two clusters. Those clusters, I will label it as apple and orange. So it can be like dogs, it can be for animals, for vehicles, and for fruits, anything. So that is unsupervised learning. It does not have any supervision. It will automatically, based on the features, it will start clustering it and grouping it, and it will give me the next prediction of whatever the next little bit of features uh, that I provide. I will get an answer accordingly. So that is unsupervised learning. And reinforcement learning is like, for example, I can give you the reinforcement learning as the driverless cars these days, and playing games. So driverless cars do not evolve automatically. So what happened is that car actually started moving, and then as soon as it moves, like a robot, as soon as it moves, if it finds an obstacle, it might fall once or twice or maybe a couple of times, but next time it knows that after a couple of steps, if there is an obstacle, it has to overcome that obstacle, and then it has to either go around or maybe hop or wait until the obstacle moves. Just like, if the car is actually stopping at a signal, if pedestrians are moving, it will wait until the pedestrians have passed through the road, and then it starts moving. So that is reinforcement learning, where the algorithm learns through trial and error and finds appropriate action for better results. So that is reinforcement learning. So I will actually have all those question and answers. So whatever the questions that you have, please type it over, and then I will answer all of them by the end of this session. So coming to the statistics, pretty much like we are just scratching only the surface here about the statistics. It's a branch of mathematics which is dealing with the collection, analysis, interpretation, and presentation of the data. So whatever data that we give, it actually tries to collect it, analyze it, interpret it, and then we have the visualization for the statistics. Whatever the graphs that you see, the histogram, the bar chart, all those are based on the statistics, which is again the statistics. So data overall, any kind of data that we have can be classified into quantitative and qualitative kind of data. So the qualitative data is something which gives me an insight or like an understanding or even defines the characteristic. Like if I am wearing a blue t-shirt, then okay, your t-shirt is blue, or maybe based on the skin color, or maybe you're tall, so that means like somebody's characteristic is being defined by the qualitative data. Like if you taste the food, you're getting the insights of the food. The food might be sour or it might be sweet and so on. So that is the qualitative data. Like you can define the gender, the nationality, or the texture, the feel, the smell of the food, or the taste of the food, etc. So that is qualitative. Like anything which comes into the categorical variables under of the physical appearance of any object, which can be classified as the qualitative data. For the quantitative variables, we again have it classified as the discrete or continuous. So the discrete is something which can take any integer number within its minimum and the maximum value. Like, for example, I can give an example of a parking lot. It's like, okay, a parking lot can accommodate 100 cars. I cannot have 99.4 cars or 86.3 cars inside the parking lot. So if I am defining, I will have at least, if the maximum capacity is 100 cars, then you can have anything from 1 to 100. You cannot have 0, or you cannot have 101, 1 to 100, and you cannot have any decimals like the real numbers. Discrete data takes the actual numbers like the integer numbers, and the continuous variables are something which can take any number, any real number in between the minimum and the maximum value. So let's say, for example, if you have kids, or if you are measuring your own height, every year your height is growing by 2.3 centimeters, or maybe like 3.4 inches. So it can take any value in between minimum and maximum. That is continuous variables. Discrete is always taking any integer numbers in between that minimum and the maximum of that set, right? So the nominal versus ordinal is something which again comes into the categorical variables pretty much. Nominal is just that I am labeling something as nominal, or this is also called as the categorical variable. Nominal is like this place is India or Hyderabad, or the state. And any state, for example, if I have New York, Florida, California, San Francisco, all these are states. It doesn't have any sort of order like New York should come first, San Francisco is second, until I have anything, any other numbers associated with it. Like the population, okay, the highest population can be New York or something. So unless I have any numbers associated with it, these nominal variables can only be the labels for any particular object. It can be like a dog. I just label a dog as a dog. That's it. It doesn't come first, second, third, or I don't know where to place it, but still, it's a label that I have put for any particular animal or an object. So, and ordinals are based on the scales. It's like if we have, let's say, if I give a survey, how was this session? How would you rate this session from 1 to 5? So, is it like, 5 is too good and then 1 is too bad? That has a range. So, 5 stands first and 1 stands last. So, this has an order where I take the order of from 5 to 1, and but nominal variables does not have any orders. I hope this is clear. Ordinal gives you a scale which again can be uh, Ordered and can also be sorted like ascending or descending. I can sort it, but nominal values, it's just a label. It cannot be sorted or it cannot be ranked. So the spread of data for the statistics, which is very high level, we know mean is the average of the data set that we take. You don't have to sort it ascending or descending. You just have to take the average value of that particular set. That is mean. Median is we always have to sort it and then take the middle value. That is median. When we take the median and then the lower half of that value is called lower half of that set is called the lower half, and then the upper half is the second half. In that half, you again split it or take the median. That becomes your lower quarter and the Q1 and the Q2. And the upper half, if you split it again with the median, then it becomes the Q2 and the Q3. In between Q1 and Q3, we will have the interquartile range. The data or the range between Q1 and Q3 is the interquartile ratio. So the lower half median and the upper half median will always come into the interquartile, which contributes for the interquartile range. If you see, this is the box plot, which we call it as the upper whisker and we call it as the lower whisker. So we have the quartiles here, the upper quartile and the lower quartile. The difference or the range between upper quartile and lower quartile will always give us the interquartile range. And this is used mostly for, in terms of the population, in terms of all the census data that we take, in terms of water levels, in terms of the population, anything that we want to measure, we always have this interquartile range. Or even for the marks that is obtained in the school, we will always have this upper whisker, lower whisker, and the people who are at the first rank and the last rank, and we always will have this interquartile range where most of the population falls under. So that is the interquartile range. So enough of statistics. Now we are going to move to the machine learning algorithms. So in machine learning algorithms, regression and classification, like as I mentioned, for the supervised data, we have regression and classification inside the supervised. And for unsupervised, we use clustering as one of the algorithms that is used for unsupervised data. And for reinforcement, there are multiple algorithms like the ResNet or LeNet, which can also be used for the reinforcement algorithms, including the convolutional neural network. So now when we get into the regression, we regression is based on the kind of data that we have. So if we want to predict a data which is the continuous range, like I want to know the customer lifetime value in an insurance industry, I want to know the salary of a person based on his age of experience, then it is a continuous data. It is not yes or no. It's not like the classification which is 1 or 0. I am predicting the salary. That's like a real number, which I am actually predicting it. So that kind of data, which if I am predicting the SLA, if I am predicting the target, if I am also predicting some of the, the lifetime value or the gross salary or any other continuous variables, that is where I use the regression techniques. Regression techniques are used for continuous variables, predicting continuous variables. And classification techniques are used for the probability. Classification techniques are used for true or false. It's mostly like yes or no, whether this person will buy a car or no, based on the ads, based on the information that is provided, whether this person will buy this car or not, based on the information. Like you can go to any other store that you have, any grocery stores, and if we have certain um, if we have certain items placed at at certain rack, and then there is a prediction for everything, whether this person will really buy this item or not, and where should I place it for this customer to buy the items. That's a different topic. But at least at this point of time, based on whatever the items that he has bought today, will he buy this item next time when he comes to the same grocery shop, is something that is a classification technique, which we will say yes or no. We will not debate more on that. So this is the regression. So here comes the regression topic. So in regression, we have many algorithms. Even decision tree can also be run for the regression. So right from the beginning, like we start with the linear regression, and then we go to the multiple linear regression, then we see the polynomial regression, and we have the decision tree regression, and at some and we have in some of the uh, for some of the data, we can also have random forest also run for the regression techniques, so which can predict values. Random forest is not only the classifier, it can also be used for the regression techniques. Now when we talk about the regression, so let's see what is the regression, linear regression, and then how the formula for the machine learning regression, linear regression, is built upon. So linear regression, which is always the formula of m is equal to x plus c, or we can also say y is equal to beta naught plus beta 1 plus x, beta 1 into x. So that means here y becomes our dependent variable. Please bear this in mind. Y is our dependent variable and x is the independent variable. That means the x is the number of years of experience, which is again on the x axis, and the salary is on the y axis, and y is dependent on x is not dependent on y is dependent on x, and that is why the rate of change in of x will also help us to know what is the rate of change, what is the change in y. That means dy by dx. So because this is linear, we can take this into a small coefficient, which is beta 1. Beta 1 is again a slope. uh, I can have a small, paint and then draw. So let's say if this is my, angle, or this is my best fit line that is, that has come up. What we do is that for every point, in x, we have a slope. So that slope is the beta 1. And this slope is always defined by, let's say, so for the change of the number of years in x, for the change of number of years in x, let's say if x is moving from 1 year to another year, the change in y is what we have to determine and what is predicted and what we will know, right? So if this is my y-axis, y-axis, and if this is my x-axis, which gives me the number of years and the salary, here the salary will change based on the number of years to an extent where it is not straightforward, but it is linearly associated with it. It's linearly correlated. That means the change is completely dependent on the beta 1. As and when the beta 1 moves from 0 to n, x also increases. In case if x is 0, then y will become the beta naught. That means for a 0 years of experience, y will become somewhere around 34,000-35,000 salary. So for the number of years, even for an employee with 0 years of experience, he will certainly have the salary of around $30,000-$35,000, which can grow based on the number of years. And it also depends on the number of, it completely depends on the number of years, because that is the only variable that we have here in the linear regression. But over a period of time, in the next demo, what we do is we go through the multiple linear regression. And in multiple linear regression, we not only have the beta naught, we have beta 1 x1, beta 2 x2, beta until beta p x p plus the error. We'll talk about the error later in depth, but until there, we have so many other variables that actually come into picture when we are talking about the profitability of a company. The profitability of a company is dependent on the administration, the R&D, the marketing spend, and so on, and the place where they are located, or or situated or based at. So this becomes your multiple linear regression. There can be multiple examples, and and in the real world, as I mentioned, or as we can talk about, in the real world there are very few linear regression examples that we have. There are hardly any data that we can directly say which is, which any dependent variable is dependent on only one particular independent variable. So here to take you through the examples, what I have come up with is to uh, I'll talk about the R squares. So here now, this how did this line come, and how did system or the machine learning algorithm identify this as the correct line? This line is based on the R squared and the adjusted R squared. R squared is where we have the sum of the residents. Let's say I will take the MS Paint again, which I've to show you. Let's say this is my line, and then there's one which value which is predicted here, but these are the actual values. I see these are my actual values, but how did the algorithm define or decide this is the best fit for this particular um, data? So how did it decide? So let's see. So let's say these are the predicted values, and we have these are the actual values. So what happens is it it takes the difference difference from this particular point on to the best fit value or the fitted value. It's also called as fitted value in some statistics books. It's also called the fit value in some statistics books. Based on that, what we do is the data that falls on this line are called fitted values, but these are the actual values. So if we take the actual value minus the fitted value for every data point that comes on this projected line, and then we take the sum of squares. The sum of squares come here like this. The sum of squares, that's yi, which is the actual value, yi hat, which is the predicted value. You take the square of that, and you divide that by the median value. This is my median. For this median also, I will have different sum of squares. So I take this sum of squares on the median and sum of squares on the actual, and we do that. And this sum of squares of total is the sum of squares of the median, which I just talked about, and sum of squares of the regression is the sum of squares of the fitted value. So 1 minus this value will give me the R squared value. R squared, the minimum R squared value, whichever, algorithm goes through this line, algorithm goes through this line. It also checks like, okay, this line, what is the R square value? What is the R square value for this? What's the R square value for this? It does multiple combinations and finally comes up with the least squared value. The least sum of squares value is the one that actually comes up with the best fit for this line. So that is where it defines this is my best fit and this is my least square value. So you must have heard about the least sum of squares, R squared, or the least sum of squares of the value, and algorithm does this automatically. through the code, and then it gives us the best fit line. And this is how I will be able to predict, although these are also called errors, and we will certainly have some of the errors. But over a period of time, if we have you know thousands of rows of data or millions of rows of data, and then if we continue to train, we might increase the accuracy of it for the prediction. But never expect 100% or more than 95, 98% accuracy. If it is 98% accuracy or more than that, then I would see that the data is fake, or it is not really like the real time data or the industry related data. It is something that is manipulated only for the sake of sessions or for training purposes, but it would not be the real time data, because you cannot expect a system, however accurate it might be, it will not go beyond the 96 or 98% accuracy. So that's how the system works. And we talk about the adjusted R squares as well. In the adjusted R squares, it's pretty much like this R squared only. And the reason why we bring in adjusted R squares is, if we go to this multiple linear regression and there are multiple variables that come into picture, and then every variable that comes into picture, the adjusted R square, if we see the p is the number of variables, and n is the number of rows that we have in the data. So the number of variables that we have and the number of variables that are used for regression. So please keep in mind, so I have the id, I have some other column name, date, time, and all these ids or the columns which I'm not using it for the regression at all. So in those situations, then I'm not counting those as the number of columns that are used for my regression purposes. So only those which are fit or which can be used for regression are the ones which we consider as the columns for regression purposes. So that is the number of columns that go in here for p, and n is the number of rows that we have in the data. So the number of regression columns, the number of the regressor columns increases, the data will come down. I mean, uh, the value goes down, and 1 minus uh, 1 minus this value will obviously go down, and the adjusted R squares will also go down. So this can be increased because the number of rows minus 1 and R square. So 1 minus R square will anyway give me the lesser value, because if the R square is more, anyway, which we are expecting it to be more, and then if R square is more, then the 1 minus R square will become less. The lesser the value of this side, 1 minus of lesser the value will give me a better adjusted R square result, which will lead me to the accuracy. So that is how we can explain the adjusted R square and R square, and the difference between R square and the adjusted R square, why we always choose adjusted R squares uh, for the algorithms which or for the data which is more than 2 or 3 columns, which comes into the multiple linear regression. So here on, maybe I can take a stop and ask for questions, or let me, in the interest of time, which is already 3:20, 3:40, so we have 20 more minutes, and I'm going to take you through the Python. Again, in the interest of time, what I have done is to prepare the code, and then for simple linear regression and multiple linear regression. So I will walk you through the simple linear regression and multiple linear regression. For Python, I have chosen Spider. We have many interfaces for Python. Even you can open the Sublime text, just like the Sublime text that you have, and open this Sublime text, and where's my Sublime? Yeah, and then start writing Python code. So sorry, but these codes, but what I meant was just open any Sublime text and then start writing the Sublime code here, and you can run it through the Notepad or run the Python code through Notepad. So it is not a big deal. For Python, we have many interfaces. All you can do is to just import those libraries, whichever interface that you are running, and start running this code, which anyway you will get the answers for. But for R, as I mentioned, we have R Studio and R. So you can go to Google, Bing, wherever you want, and then you can download R as a software, which you will find it like if you go to R download for Windows or any other platforms that you're using, you will get this grand.r project. Go there, download for any of the operating systems that you're working on. Along with that, please download R Studio as well. This will give you only the compiler. This will give me the interface, the IDE. Okay. So once you install the R Studio, this is where the IDE, the R Studio you will be able to launch. And you can see all these four windows. This is for the global environments. This is where you can see the files, the plots, the packages, the list of packages that you've installed. This is like a helper. And this is where you can see the results of the data that you're running. And this is the console. Okay. And when we are starting about the console, all we need to do is the first thing that we do always in R, especially in R, is that we have to set the working directory, set working directory, set WD. And I have taken this as my working directory where uh, I have taken this as my working directory. This is my working directory. Okay. So here I have set it, and then we can take it forward, go to the data set. So let me set this and run. So if you're running or if you want to run any particular line, it's control enter. For Python, it is alt enter. So I'll take you through the Python also. And then after the working directory, now we go to the data set. Data set, I have chosen the data set to be as one of the data sets, which is salary. Let me show the data set. I'll open the data set here. We'll show it to you. This is completely a fake or a built-in data set which I have I have prepared it only for this class purpose. Okay, this is based on the industry standards, but it is not completely the data that is being fetched out of any other uh, any other company, or it is not related to any other uh, you know tutorials or any other. I did not even find it in the GitHub. So this data is what I have built it on my own. So let's say, for example, for the salary of 1.1 years, the years of experience of 1.1, the salary will be 38,000, and going on to at least ranging from 1.1 to 20, we will have $200,000 as the salary. So this is a data of 50 rows that I have, and which we will run through, and I will show you how exactly it works through. So data set, if I am importing a data set, the command that I have is read.csv, because it's a CSV file, and then I'm importing that into the data set. So as you see, this is the data set, and the same data that we have in the Excel file or the CSV has already been imported into the data set. So the basic or the thumb rule of any machine learning algorithm, which always comes up as this: any classic machine learning algorithms or the neural network techniques, anything, even if you're working on a deep learning algorithms, the first or the thumb rule is always finding the data based on the problem statement. Here what I'm doing, I'm finding, or I'm trying to predict the salaries of a certain years of experience of any employee for that matter. It's just for the sake of training. So this is the purpose, and finding appropriate data for correct analysis. Yeah, I have appropriate data, which also says that I have data from 1.1 to 20 years, and where I don't have any nulls and all the data looks appropriate. Even if I plot the graph, I will not have any outliers, and this is pretty good data. And then exploratory data analysis, which is always important for you guys to understand how what or how your data is exactly. Like if you have the data and do you have nulls in the right data, what kind of columns do you have, what columns means what, and what exactly it means to that column means to you, and whether do you have nulls, and whether do you have outliers. Outliers is also one of the important aspects, and there's a big um, topic about outliers, whether do you want to consider outliers when you are predicting it, or do you want to not consider it, or do you want to make it like, bring it inside your data range, or do you want to take it outside your data range, or so on and so forth. Like, what exactly do you have to do with the outlier, and whether that outlier is actually telling you a story. Because outlier, if there is a data about outlier, then what exactly is that? There, the data has come in, and if it is an outlier, then we need to know why. What exactly does this mean? That is when we'll be able to build an appropriate model. So some of the systems or some of the teams, if they move the outliers or remove the outliers and then focus only on the average data, uh, which is not, you know which is not really appropriate or not suggestive or not recommended to do such kind of models. You will not have, or nobody will have a good accuracy with that, because always the system or the algorithm will keep looking only for that kind of data which is there within the range of data which has been trained to it. If you train with outliers, then you will have a wide range. Then your training algorithm with a wide range of data, and it will understand even if there is any outlier, the algorithm will surely understand that it is an outlier and take it forward. So that is the reason why we need to understand. So for which we have to visualize it, plot the graph, look at the, whether it is left indented, right indented, whether you have a bell curve, whether the, whether you have a, right spread of data, how the data is spread. All these are very, very important in terms of exploring the data before you even predict the model, before you even apply the algorithms. Because uh, we need to understand, or one needs to really understand what kind of data that you have to apply what kind of algorithm. We cannot just say, um, like, okay, if I have the regression, then I will go with multiple linear regression or the decision tree regression, and then try to do something, then try to understand what the data is, which is not the right method. First, we need to understand what is the data, how does it look, what exactly is the spread of data, and do we have any nulls? How do we replace the nulls? Do we take the average, mean, median, or 97th percentile, or do we take the 50th percentile to update the nulls, or do we ignore the nulls? So all these possibilities comes under data exploratory analysis. Once you have the data which is clean, more than half of your work is already done. Then the next job is always to fit and train the model, like fit the model with appropriate algorithm. Either just like talked about the regression, or you want to go towards the deep learning techniques, and you want to do the classification. So what exactly do you want to predict is where the algorithm lies. So in that uh, algorithm lies in that particular area, and apply the prediction. So you apply the prediction after you train the model, then you apply the prediction. I'll talk about the validation also next, and then visualization. So once you have predicted the values, then the visualization comes into picture, just like that, where I say, okay, this is my visualization chart, and I see that the line fits perfectly fine, and I should have at least about 95% accuracy. So this is where your visualization comes into picture. So let's go back to the R. Here, once I've read the data, now I know the data is clean. There's a package called CA tools, which is, which I've already installed. If you have not installed, then use this install.packages of CA tools. So once the CA tools is called in, then there's something called a set seed. This is just the random set. I mean, we are setting the randomness inside the inside choosing the data. Because if I split the data directly without setting the seed, then what happens is it will just take the first 70% of the data straight and then put it in the for training, and the 30% will directly be taken for the testing, which is not correct. Because my data, the spread that I have is first 70% I have it here only till 12.8 years of experience, and the rest is only 13 to 20. That means the trained data is not equal to the test data which I'm providing. So you should always have the randomness when you're choosing the trained data and the test data. So that's why I choose set seed 123. don't worry about 1 2 3. You can use 121, 101, 95, 123, any other data set that you, any other randomness that you want. And then what I do is, here I'm just assigning a variable fragment and I'm sampling it to split the data set based on the salary. Salary is the column based on which I'm splitting it. I'm sample dot split and data set of salary. Split ratio is 2/3. So when I say 2/3, then what happens is 70%, like 2/3 of the data which is taken it randomly, it will set it to true. So it can set from 1 to 1 to 10, and then it can take it from 35 to 45, something like that, but it should have 70 rows randomly chosen, but all will be set to true. And that's where I will assign those variables into the training set, which will training set with the fragment equal to true. So what happens? Fragment equal to true. All of the 70 sets will 70 columns or rows will come in here, which you can see. It's not straightforward. So as you see, this is being randomized, and we have taken the random set of values. And for the test set also, we've taken the random set of values. So here in the test set, if you see, then we get the random set of values. So then what I do is, there's a library called linear regression. Sorry, there's a library called LM, linear model. So fitting, now we have come to the place where we have split the data into train and test. So we are going to train our linear model using the linear model library, and then we give our training data set, like 70% of the data set that we have assigned as training set, which we will give it to our linear model and ask it, and let it train. Like it will understand the pattern. Okay, so if there is a difference between 2 year difference between 4 and 6, and if there is a difference between $20,000, so for it will understand, okay, for 2 years $20,000. But it's not the same case in every other rows and every other column. So it will understand what kind of pattern is there for its prediction. Later, when I say, so what I'm doing here is that formula is by default used by R, and then everywhere you have to use formula, although the variables will change. Salary versus years of experience. That means this is what I want to predict. So first you need to put the predicting a dependent variable versus independent variable. Because this is linear model, you will have only two variables, dependent and independent, and the data which we are providing it as training set. So if we run this linear regression, now I have trained the data. If I look at the training data, so this is one of the biggest advantages of using R. You will get this summary. You cannot get this kind of summary using Python in without using any libraries. But it's not like you cannot, but R is mostly used for the statistical interfaces and statistical calculations, and that is why the libraries in R are very, very good. And you see this coefficient and intercept. I talked about the B naught. This B naught, what I talked about is the intercept here. This intercept is at 31,792. So that means if the years of experience is 0, although I have not given, it has intercepted at 31,792 with the standard error of 1935. That is what we can see. And the p-value, I'll talk about the p-value a little later. So the years of experience is obviously, this is one of the other coefficient, which is very highly significant to the predictor, or uh, uh, to the predicting variable. So this is our summary, and you see this R squared and the adjusted R squared, which is close to R squared, and adjusted R squared are pretty much the same, except for the third point or the fourth decimal issues. Fourth decimal difference, 986.986. That means I have 98% accuracy on my system. So let's go through this, and then we see this as the predictor. Now if I predict it, I use this as the predict. Predict is one of the other, the functions, and then you have the linear regressor, which I have already trained the model, and then with the new data as test data. So now using this as my predictor, what I do, if I use this predictor and open this, I see this, I already have the prediction. And if I use, this is a ggplot. Okay, so in the interest of time, I'm going to just run this and let you know like how how the fit has happened. This is the best fit of all the models, although it will try with multiple options to fit, but it always chooses the least sum of squares of the values, and then it'll give me the best fit in the best fit plot and best fit data for the predictions. So if I, let's say for example, there's one more thing which I wanted to show you. So like if there is any other a data, let's say, so of all this data that it has already predicted, so I'm using, let's say I give 4 different values which is not already present here. 16.5 is there. Yeah, so let's give 16.5 just for the sake of validation. 25.2, 12.5, and 6.7. So how do I test my model if it is working fine for other data, not only this data? So for other data, how do I test is use import that data into the test set variable. Once you do it, anyway, you've already fit the model here, and then you have already used the predict function to use the with the linear regressor which you've already fit. Now we are taking it to predict the test set 1. So if we see this 15 4 50 159,492.45, let me take this, and for 16.5 if I use this, so I have very minimal difference with the prediction. So the actual data is 158, but the predicted is 159, and we have about 600 to $650 difference in between the predicted value and the actual value. So this is how we do the prediction. This is how we predict the you know the sample data or the unknown data which we feed into the system and then we predict it. One of the best uses of R is also where you can use the R services directly from SQL Server, run this, and then once you have this model like predict, and then all you need to do is have another Excel file or a table column which you need to call an R service with the new data equal to that particular column, and then you will get the predictions. This is one of the best uses of R services. And for Python also, we can create a pickle file after the model is prepared, create a PICKL file, and then put it somewhere, and then you can call that pickle file whenever you want to predict some other data. It will run through the model and then it will give you the predictions. So let's go through Python quickly in 1 minute, less than 1 minute. So these are the libraries: Pandas, NumPy, and Matplotlib. I'm sure you would have heard about all these libraries on a daily basis. Even if you open any browser for news, you will see NumPy and Pandas always. So again, I'm importing the data set. So if I want to describe, this is also one of the features in data. So describe the data set. So in exploratory data analysis, this is the first thing that we do. You count it, you do the mean, standard deviations, you find the minimum 25%, you find the minimum, the first quartile, the second quartile, the third quartile, and the maximum. So once you see this data, you will clearly understand the data is perfectly fine, everything is sorted, and all I need to do is just go with the split. So here, the data set is the data set that I have here, which I have imported, and everything dot colon in within the square brackets is always everything within in Pandas and in NumPy. And when you do this with -1, everything -1, that means the last column, everything except the last column, you will have all these values assigned in y equal to dataset dot ilog, and then everything with 1, that means from 1 afterwards everything. But in dataset we have 0 and 1 and everything. What happens is it will just take only the last column because there's no other columns that is present here. So there's another library, scikit-learn. Scikit-learn has all these algorithm libraries, and this also has the scientific learning kit, which will help us with the train and test split. So I split it, And where I choose the random state equal to 1, that means the test size is 0.3, train size is 0.7, which will be by default. And then I use the the x and y that I have already split here for the predictor and the dependent and the independent variables, and I give the random state equal to 1, which will anyway take it as a which will take it which it will assign all those random values over here in x and y. So again, with scikit-learn, then there's another model called linear model. I mean, this is another package, and we have a class within the linear model. Then this is the linear regression, and this linear regression, I'm instantiating an object of that linear regression as the linear regression itself, which I will fit it. So linear regression have multiple uh, methods here, like fit intercept, intercept, transform, rank, singular. So all these are multiple methods that are there inside, but I want to see the fit because I'm predicting only the linear data, which is like only the dependent and the independent variables only two. And that is why I'm just giving x train and y train to fit the data. So that means it will just start understanding the data based on the number of years of experience, what's the kind of salary that it has to be. And later what I do, I use the same linear regressor and then I use the predict with x test. I'm not using x train. So x test is the data which I have split it. I'm not giving y test. Remember, this is only the number of years of experience, it is not the salary. So that means if I just feed only the number of years of experience, y predictor will give me the salary. So if I just run this y predictor, it will give me the predicted salary. Then it will actually start looking into what is the predicted value, what is the actual value. It will minus that. I mean, it will subtract that data, take the square of it. That becomes the sum of squares. And it takes the average of the sum of squares, which also will become the sum of squares of total. That means the mid value. So sum of squares of total, sum of squares of residual divided by the sum of squares of total will become the r square. So 1 minus that will become the r square. So if I just use this as one of the methods, I call this, and 31420 is my intercept. That means this object b naught. So once I have these values plotted, I mean these values predicted, and if I plot the value, I again get the same value, same kind of plot, which will show me this is the value and this is the best fit for the data that you have provided for the prediction. So as long as your data is fine, as long as your data is really good, you will have a good accuracy. If the data is not good, algorithm will be trained in a wrong manner, and that will not help for better prediction. So there's one more, which is R2 square. It's not as straightforward as in R. I just do the summary and then I can get the complete list in Python. So there's another package called metrics in sklearn, the library, and then under which we have this class R2 score, which I can call in for with these variables, the y test and y predictor, because these are the two which are different right now, because y test is the actual value, y predictor is the predicted value. In 200 is where I can get the percentage, which actually gives me a 97.853%. As I said, this data is not the real time data. This is just for the sake of training purposes, and hence we are getting 97% accuracy. So with that, I will stop here because of in the interest of time, and then I can take questions. For the next 5 minutes and try to stop it accordingly. Do
Yeah,
we have
Deepak, yeah, before we continue, I just have a couple of slides. I'll just go through them and then we'll continue with Q&A.
Sure.
Yeah, thank you, Deepak, and hope all audience understood what is linear regression, etc. And you can, while I'm going through these slides, you can ask your questions. You can put up your questions in Q&A panel, And beyond this webinar, if you want to ask questions, you can use these social channels, Facebook group, LinkedIn group, and Telegram channel to ask questions. And today's screenshot was put up in a LinkedIn, and the link is there available in chat window. You can provide feedback there. So please provide your feedback that will encourage speakers to come back and deliver sessions for you. So please put up your comments there. And SQL Maestros is coming up with a video courses. And there are a couple of video courses, SQL Server Performance Tuning and T-SQL Querying and Programming. So video course is for example, SQL Performance Tuning video course has more than 100 hours of content, which is advanced deep dive and expert level modules, which are constantly getting updated. So the main advantage of video course is that you can watch anytime, anywhere, and as many times as you can. So if you want to learn more about SQL Server video courses, you can visit sqlmaestros.com, or you can also write to contact@sqlmaestros.com. If you can visit that bit.ly link to know more about SQL Server video courses by SQL Maestros. And SQL Maestros also offers hands-on labs, which are a step-by-step self-paced learning solution where you will be provided with a document. You just go through and follow the steps in the document along with observations and explanations. At the end of the session, you'll be able to learn a topic. So that's what this hands-on labs is designed for. If you want to learn more about hands-on labs, you can visit this bit.ly link, or you can write to contact@sqlmaestros.com. So there are a lot of free webinars and in-person events lined up from Data Platform Geeks. Here are the list of few, and there are few more on Data Platform Geeks website. So there is one in-person event coming up this Saturday, 23rd November in Hyderabad, where Deepak is also taking up a session on machine learning, and few algorithms he's going to cover there. And there is one more session on SQL Server in-memory OLTP as well. And there are a lot of webinars lined up on all the technologies: Power BI, SSIS, Azure Data Studio, Azure SQL Database, and machine learning, everything. You can find out all the events there. So if you want to attend and register for any of the events, you can visit dataplatformgeeks.com/events. So with this, we are going to conclude this uh, webinar. So thank you all for attending this
I
webinar.
think there
And
is one question I see
yeah,
here.
yeah. I'm
Sorry,
handing
sorry.
out.
Yeah.
Yes, I'm handing it over to Deepak to take over the questions from here.
Yeah, I see a question here which also says from Indrajit, if the results vary with R versus Python. Certainly, yes, results do vary from R to Python. I can show quickly, share the screen. Or yeah, so the reason is R is a statistical software, and the way R is built, or the library package, or the methods that is being used to find the best fit, just like the sum of squares of the residual divided by the sum of squares of total, and the one minus sum of squares and of the residual by total is where R squared is defined. So when you are understanding, or when there could be a different way R is implemented, and there could be a different way where Python is also implemented. Whichever you find it as the best accuracy, you can use that. But at the same time, uh, it's not really significant. So in case if you have this R's difference, or R is at the accuracy of 98.66, and Python can have a accuracy of 98.42 or 98.44, which is really like at the third decimal point, and you really can ignore it. The best thing what you should be looking at is how easy is for you to work on the data, to uh, you know to polish the data on the exploratory data analysis, and also to apply the algorithms, and how best you can get the visualization. Because matplotlib is a very vast library, or the package that we have, when compared to the ggplot2 that we have in R. ggplot2 is like, really, it's not that user friendly, but matplotlib has really great libraries or the classes that we have, which can be used to have a better visualization. So those are the aspects that you need to consider in terms of which software to use. Any other questions? All right, thank you very much for all the for all your support. I really appreciate it. And thanks a lot. Thank you. You all have a good day or a week ahead. Bye bye.
Thank you, Deepak. And all of you, please post your comments there. The LinkedIn link is there in the chat window. Please put up your comments. That will encourage speakers to come back and deliver sessions. Please post your comments there. The link is available in chat window.